So section 7.2, a one-sample proportion test. So in this section, we look at a hypothesis test for the population proportion P. So this is where you might be curious if the proportion of students who smoke at your school is lower than the proportion in your area, or you could question if the proportion of accidents caused by teenage drivers who do not have a driver's education class is more than the national proportion. So in this case, we are dealing with qualitative data. So proportion tests are about looking for the percentage of individuals who have a particular attribute or are in a particular category. In Chapter 5, we learned about how to use the binomial distribution when we were counting the number of successes in end trials. But then in Chapter 6, we learned that if instead we looked at the proportion or percentage of successes in end trials, that under certain conditions we could use the normal distribution instead. So for the rest of the course, we are going to be focusing on, when we're talking about qualitative data, we are going to be using the normal distribution to get these approximate probabilities. Alright, so for our hypothesis test for the one population proportion, and the input screen we have on the calculator for that is the one proportion z-test. And in the last section, we had mentioned the acronym PHANTOMS to keep the 8 steps in mind for a hypothesis test. So for the first test in all of our hypothesis tests, we're going to state the parameter in words. So the P from PHANTOMS is parameter, and every parameter has its corresponding random variable from the sample data. So in this case, we're dealing with qualitative data, so our parameter we're going to be interested in testing something about is going to be the proportion of all objects that are in some category of interest, which makes the corresponding random variable p hat the proportion of n randomly selected objects in that same category of interest. As in the last section, we mentioned that a hypothesis test can be two-tailed, left-tailed, or right-tailed, depending on if that alternative hypothesis is a not equal to, a less than, or a greater than. And so in this hypothesis setup, all of these will be symbols except for this number here, p sub 0, which will be a specified number. And it's a proportion, so it will have to be a number between 0 and 1, or as a percentage between 0% and 100%. Every hypothesis test has its list of assumptions that need to be checked. These will be on your cheat sheet, so you do not need to memorize these. You just need to know which assumptions go with which tests. So for all of them, we're going to have to assume that we've taken a simple random sample of size n. Sometimes that's mentioned in the problem. Sometimes it's kind of an assumption we make at this point. But again, we talked earlier about the need for taking good representative samples. The next thing is that we need only 2 categories for each object so that it's a binomial experiment. So again, we have qualitative data where each object is going into one of 2 categories, of which one of those categories is our category of interest for the problem. And then we're going to check that the sampling distribution of p hat can be approximated with the normal distribution so that we don't have to use the binomial distribution. And these checks that we have here are the same as we had back in Chapter 6. So we need to check that n times p is at least 10, n times 1 minus p has to be at least 10. And then if we're given a population size, which typically we are not, but if we have it, we need to check that cap n is at least 20 times little n. So if all of those conditions are met, then all of the conditions are met to use the one proportion z-test. So the name of the hypothesis test here is one proportion z-test. So proportion, we're dealing with qualitative data, the 1 because we're dealing with one sample of data, and the z stands for, the z-scores for a normal distribution, and test because we're going to be doing a hypothesis test. So the 5th step here is to find the test statistic and then the statistic or sample statistic from our sample data. Again, we're dealing with qualitative data, so that's going to be the value of p hat. And our test statistic formula is given here as well. So our standardized score for p hat is the z-score, where we're going to take p hat and see how far away it is from the claimed value of p sub 0. So we're going to take p hat minus p sub 0 in the numerator. And then in the denominator, we're going to divide then by the standard deviation, which for qualitative data, that's p0 times 1 minus p0 all over n, and then the square root of that entire quantity. And this value is we're going to see is on the one proportion z-test output screen. And then our sixth step is to obtain the p-value, which in the last section we kind of tied that back to how we could use normal CDF to do that. In these sections, as we're using these built-in screens, those probability computations are just going to be done for us in the background, and they will be on the output screen next to the letter P, but we need to keep in mind that it's actually a p-value. It's not the value of P. We're going to look at how to make a picture to make sense out of all the numbers we see on that output screen. Again, two-tailed test will have two tails, left-tailed test, a left tail, right-tailed test, a right tail. And then finally at the end here, step 7, we get to make a decision about HO, and that just depends on, again, we're going to take this tail probability, the p-value, and compare that value to alpha. And again, it's either going to be less than or equal to alpha, in which case we reject the null hypothesis, or it's not, in which case we fail to reject. And then we finally state a conclusion back in the context of the problem. And so again, if you reject the null hypothesis, it's like you throw out the null hypothesis. That means you did that because there was significant evidence that you thought the alternative hypothesis was actually correct. If we don't reject the null hypothesis, that means there wasn't enough evidence in the end to conclude that the alternative hypothesis was correct. And we're never going to say accept the null hypothesis. Again, in a hypothesis test, we assume the null hypothesis is true to begin with. So a hypothesis test cannot be used to prove that the null hypothesis is correct. So again, at the end of the day, we either reject or fail to reject HO, and we either say there is or there is not significant evidence to conclude HA.